Hey guys, welcome to my channel. I have another interesting video here today in the lab. I want to share with you guys all the improvements I have actually done in here. I have a dual camera recording. As you can see, I have my phone in my hand and I'm actually have the screen recording going on, but I will do some movement on the mouse so when we start to synchronize that all. I just want to give you a quick tour. I have still that first simulator in here. I haven't decided yet where I want to put the new simulator, which is good news on the lab here. I still love that one. That's definitely going to stay. Not sure if this is going to stay yet here. I got to get more familiar with the new setup that I bought and get again more familiar and everything. Again, just let me give you a quick tour. That's the other tripod and camera recording. This is like the corner of the movies. And that's the repair table. I keep always the most or the most urgent computers to repair. That's just some of my tools in here. That's the Pura Vida sign from Costa Rica. This last time I went to Costa Rica, I got that. Again, I got some of my tools in here. I try to keep this nice and organized. That's the my IM608 from Hotel. Another multimeter I have in this corner. Um, right now I'm using just the bench power supply to supply power for that simulator. It's like that I have a control environment of how much I'm, using. These are emulators for injectors and coils, part of that same full diesel and full probe setup that I acquire. Again, I will be talking more about this tool in other videos, and I want to show you. As you can see, I got a generic setup for now because this is a tool that I just got this week. So I talked to them and they said they can make the harnesses that I request as long as I tell them the pinouts or whatever I need. We'll see how is that because I also got some extra connectors that I request just in case I can wait and I need to do something. I mean, this is a little time consuming. Not this time because for what I need to check on this computer is something really briefly, and I want to share that with you as well. But for those that knows me and are my subscribers in here, you know that I like to create my own harnesses all the time. Sorry, I was trying to always. I will keep this for the sure view of you guys to can see what I'm doing, and then I will be more personal with the other camera. But yeah, for you, they have followed me for a while. You know that I like to create my own harnesses, and this is the way I had this other simulator. I created this harness that so I don't have to be removing pins back and forth, and I can just have a harness that I connect very quick to the computers that I work the most. So I'm going to be doing the same with this one. Again, I got to get more familiar to how this one works because it's very different than anything that I have used before. It's actually all digital, so everything is actually in the computer. So this is the software. I will be using this camera. You guys can see me in there. I probably change the angle. So that is the software. So in here, I can adjust, I can select for diesel, gasoline, gas direct injection computers, and it has a very good database. Um, Not so strong yet for USA, but it doesn't mean that we cannot use it. I mean, I can use generic and use whatever cam and crank signals that they have there. Also, this software itself, I forgot that I also have the screen recording. So I will be putting this one for now here so we can get a very close look of the actual board that we will be testing in here. So I think that will be a good experience this time. Also, I'm using the Top Done. Top Done is a fantastic tool. I'm really, really happy. I actually bought the oscilloscope because I want to try the oscilloscope in here. I got a Picoscope 6402D, which is a very strong, it's a 500 megahertz oscilloscope. But looking at the information that I got from Top Down, these oscilloscope, remember this one is supposed to be 100 megahertz, 4 channels. It's actually not supposed to be. You can see it in here. It says it's 100 megahertz. which is really good. And I like the software that Top Down has for these oscilloscopes. And it's actually very impressive because for those that work and use picoscope, the picoscope is only 20 megahertz. So it's nothing wrong with that for mechanics because it depends on what you do. That might be plenty. But if you work, as I also do, as a mechanic in a shop, they uses flex ray and fast communications. You want sometimes a little more. You want that detail. The higher the megahertz has an oscilloscope, it also gives you better how can I say that, a better resolution when you're reading low voltages. The lower the megahertz on a buffer and also the samples rate, it will make that oscilloscope then have more noise when you're looking at low voltages and low amperages. So if you have a better oscilloscope, but yeah, let's say that picoscope that I have right there is around $7,000. So I really want to go ahead and try that oscilloscope from top down and give you my insight and then to promote it more because top down it's an excellent tool. All right, going back to what we're doing in here, this is a 2000, let me see, I have the information right here. 2007 Mercedes-Benz S550 4Matic. The designation, you will see it in very short, is a 221.186. And the customer concern, which I have in here, let me actually, oh, I actually reading the information. Um, I don't want to open that. I should have prepared that. Let me see, because the problem is we are using the screen recording, and I have his phone number, which you guys already now have. I don't have his email or information in here, so I can cut this now. All right, so what I was saying is his concern is a no communication with the DME, or sorry, the ME, which is a Mercedes. So let me show you. I have prepared a little short, everything ready to go, so we can see. So he said he has no communication with the engine computer. ME is in Mercedes-Benz, the same as in BMW will be the DME. It's just motor electronics. Um, so they have no communications. I was looking at this and I saw that he has no CAN message was received from control unit 93, which is the central gateway. And that's why also I have pulled some information in here that I want to share with you. I'm going to go step by step as I, that's the wrong one. Okay, perfect. So I have, yeah, this is the gateway as we can see here. So this is the gateway. Yeah, you guys are looking at the computer in there, looking at me, and we have the screen recording. So I think it's very good right now. All right, so the gateway on this one, the central gateway control is located behind the full well cover and the cockpit, and it's cross member on the left in direction of travel, so driver side. The task that gateway has is pretty much all the kind of networks. And Mercedes-Benz has interior CAN, chassis CAN, diagnostic CAN, front end CAN, central CAN. I mean, it's different CAN networks that are not part of each other. If you see the information in here, we have the baud rate of the speed of each of those CAN networks. So I'm like, okay, you need to get familiar with what you're working with in order to diagnose properly a vehicle or a computer in this case, right? So I went and also found this is the most important part that I have for me, how you can communicate with this as far as a computer or laptop or aftermarket scanner. How do you will you be able to communicate to this computer with, I don't have the gateway here, right? You don't need to have the gateway. The gateway is a protection that Mercedes-Benz has done in order to avoid like, an intrusion or defective tool to damage the internals of the vehicle. So by the gateway having that part, okay, the diagnostic tool that you connect is shorted, it will short just that part, that communication between the gateway and the diagnostic port. The rest is the integrity of everything on, or the rest of the networks, it will be not compromised. So looking at this, it tells me that okay, laptop to DLC ping 6 and 14, and then Candy goes to the N93, which is the gateway, and then from the gateway on CAN E to the ME, which is in Mercedes is N310, and you can see it right here, MESF, that all has information, I mean, a meaning, fuel injection system, and blah, blah, blah. I mean, that's just a lot of stuff they like to put. This is also what I use to understand more or what is connected to it. You can see, they name everything like I'm really, really familiar with Mercedes. So, the N10 are the SAMs. So you got the N10 ones are the from SAM and the N10 slash or yeah, slash two is the rear SAM. Um, and then you got valves and other things in here like the coils and injectors and some other modules in here. You can also, if you want to know what everything is all here. And that's what I like to use. Uh, Original information. You have interior can B, C, D, E, F. So why is the communication in between the computer and the central gateway, the one that you're going to use for diagnostics, is try and error. I don't have the car. If you have the car, you will be able to know that immediately. I did try the CAN network F and the chassis CAN E. This computer communicates on E, which is also what we have in here. And here it doesn't tell me what denomination the can is. If we go over to here, it doesn't tell me what chassis can is, if it's can E, B, or whatever. So on this other one, it's telling me that uh, can E is chassis can. So that's the way just design it. I mean, it's that I cannot do anything. All right, so pinouts, as usual, I use pretty much for everything. As far as my diagrams, I go over to Identifix. I do have the original diagnostic equipment, which is Sentry. And Sentry, you can have Wiz, which is give you all the uh, diagrams and everything you need in order to diagnose your vehicle. But I'm not using it for this. Again, this is pretty simple, so I'm just going to keep you. All right, for most of the stuff, I always use Identifix, and it has all this information that you see here is coming from Identifix. Yes, you have to do your homework, and then for those that use Identifix, you know that you can create your bookmarks so you can revisit that information, and it works really, really good. One thing that I always go is to see which ones are powers and grounds and all that, and I save that information over to the folder on here. I can also have the computer networks, so we can see that. And this is the color one. So this is not the OEM. This is the color one. And here it's just telling me that you see it's like it's a little inconclusive, and that's why you need to do your homework because in here it's telling me that the ME, the engine computer, communicates to the gateway, what they call here drivetrain CAN voltage distributor connector. Actually, this should not be right frame connector. I'm not sure if this is what they call the actual gateway, because the gateway actually has the different name. It's just central gateway. I think that what they refer here on this is, again, for those that work in Mercedes, and so you know how you got those X connectors or C connectors where all the cans are. You got the body can, the chassis can, and all that different one. But again, so this is, I save all this information and that's all I could see. Vehicle dynamics, voltage, CAN voltage, distributor connector. So yeah, this is, again, it's just those like the star connector that we use in GM or so, right? So I'm just going to scroll a little fast on here. Again, these are just connectors, not gateways, but it's a little. Or I was saying, sometimes this can be a little intimidated. You got to get familiar. If you're working with something like this, take your time, go home and do your homework, because that's the only way that you will be successful in diagnosis or in repair, right? All right, so one only thing that I did connect in here in order to see if the computer works. So I got powers, I got grounds, I got the can high and can low, which I already know is in can E. Yeah, I got my pinouts in here. Chassis scan is scan E. That's the one I'm using to communicate. Then grounds are pins 2, 4, and 6 in connector C2. The connectors are marked 1 and 2. So connector 1, I think is like 60 pin, and this one is like, or you will see this is connector 1, the one with the most pins, and then this one with less pins is connector 2. Most of the pins that I'm using are in that connector 2. So again, I'm going to repeat. CAN E, which is 41 is CAN E high, 54 is CAN E low. That's for communication in between this and the scanner. Grounds, pins 2, 4, and 6. Those are big pins. Powers, we have 3 and 5 battery. Pin 16 is the wake cap, which is super important. And then pin 15 is ignition. Those four has to be done in order to communicate with this. I also have a separate wire here for the 5-volt reference, which is again on connector 2, pin 22. I got only on connector 1, as you can see, only one wire here. This is the coolant temperature, the ECT. So that will be pin 66 on this connector. I found all this. This is the one I have here. I want to share this with you guys like that, because if you go over to these color wire diagrams, you will see that there's no way to know what is, because you're going to see and you're going to tell me, okay, well, pin 66, yes, you can go over to the sensor, which is right here, and I mark both wires. Again, I like their latest version of Identifix because you can select all the diagrams, but now all connect together. So when you touch in anywhere, I will select the entire path of those wires. So when I minimize this a little bit and I go here, I can see that this one goes to the DME as we saw before, right? But this one doesn't. Okay, but this one that doesn't go over to the DME, it looks like it's being shared, right? Again, this is a thermistor. Thermistors are completely different than a TPS or any other sensors. You got in a TPS, three-wire sensor, you got power, ground, and a signal wire. Most of the times, you're going to have a ground, a 5-volt reference, and then a signal that is produced from there. Uh, That 5-volt reference, which is just again a power and a ground, the signal will never be shared because it goes straight to the computer. The power, which is a 5-volt reference, can be shared because it's just a power, it's not a signal, and then obviously the ground as well. On a thermistor is a completely different because that wire that you have is only a ground and the signal, which is actually a 5-volt reference that is coming from the computer and is being pulled down to ground through a resistor, which is the thermistor inside that sensor, and the electronics internally on the computer are completely different. That 5-volt reference is meant to be pulled down. So you can take that wire and touch it to ground, and all we'll do is mark, 240 degrees of temperature or whatever the maximum temperature is. So the only thing that this can be sharing on that sensor is the ground. That signal cannot go into anything else because it's the signal. So that 5-volt reference that you will see in there is not really a 5-volt reference, it's the 5-volt reference signal for that thermistor, which is a very unique design. Okay, so if this is shared, that's not my wire, the order is a signal. So that's how I figured out that that is the signal that I need to um, provide or to use for the coolant temperature sensor. All right, so now going into what you guys wants to see. Again, he's concerned, no communication. I have already I have power up into Again, the full probe, which is not just this what you're seeing, is also have so that one in there is a full probe, which is connected to the full diesel, which is also supplying injectors and other things. Let me actually move these cables out of here. We're not using, trying to organize this a little better. Again, this is just a week, less than a week that I got these tools. I'm trying to uh, make it a decision of where I want to have it, right? Again, but okay, this is the top down BCI Pro, or I think yes, that's the name, MCI or VCI Pro. It's touchscreen and everything really good. And it says right now that we have no communication for the vehicle at present. All right, so this is again the full diesel. So these two are connected in between, and they have to be connected in order to work. It's just the way the system is. All these connectors, it got different configurations for like I can do immobilizer, I can do dashboards, I can do fuse boxes and BCMs, sorry, BDCs, like for BMWs and all that stuff. There is um, a smart systems, right? So that's what I bought this one because in here you can put the keys and for all the immobilizer systems. So this is really, really, really good. All right, so going back to what we're doing here. Let me get, oops, sorry, that might be a little abrupt. And let me move this a little better so you guys can have a better angle. This little tripod has a little more legs that I can actually put in here so you guys can see better in there. And I think might be the best position for you. Okay, cameras are all working. All right, so now we know powers and grounds and we know what I'm doing in here. The software that we use again is from these companies CEA, and they're from Argentina. So I got power. Yeah, everything is on. The switch for this one is on the side. I would show probably more of the equipment and future videos. So I can, terminal 30 is battery and terminal 15 is ignition. So this will be the first one that we will turn on. And then the second one. Um, Now we will try to communicate with this computer is to see if this computer is alive or not. So we're going to try to do an auto scan. Just remove one ground in here just to see because all the grounds are connected in between. So this is not really necessary enough for because I'm not putting any loads in here. So not having one ground connected ain't going to affect my communication. I have all the powers. And I can see that I do have fiber reference in here, which is, hmm, and let's reset everything back again. Oh, one thing that I might be, oh yes, this is right here. Ha ha ha. You see, this is what happens when you're not used to the software and everything. When I'm working with this simulator, I know that I have to provide my own CAN terminator resistance. I have to put that in here. Nice thing about this software, I can provide that here. Hmm. Activate protection. Oh, it was locked. You see, it's like, all right, so I got it on. Now I can close this. Just gotta get used to this tool more. All right, let's try this again. Um, all right, so you guys will be seeing this. Oh, we got 36 minutes. I'm gonna have to cut some of these because it's too long. All right, so let's do auto scan. Okay, that's good news. That is good news. And that is if, let me check, oops, sorry guys, let me check the bin number with what he sent me. And we have that here. And it's WDDN G86X77A 131A45. That is 100% correct. All right, so yeah, that is our computer, no doubt about it. Okay, so now we need to see, we're going to do quick access. We can do a scan of quick access. I don't think it ain't going to matter. Up to 2009. Perfect. Yeah, the ignition is on. Yes, and here we're gonna go down to where the ECM, this is top-down name, not actually how it's supposed to be, but it is the ECM. All right, so we're gonna enter there. I don't know, I keep asking if the ignition is on like 30 times. We can read full data. Yeah, no pressure sensor connected. Pressure sensor short circuit depositor or open. That is, I have to take a look at that one because I think the pressure sensor on this computer is this little boy right here. Just to make sure, we will check that out. Make sure that all pins and everything are good and no corrosion. But again, that's not what is here. And it's not really um, uncommon that since nothing is connected, it reads abnormal. It says current and a store. I mean, we have a whole bunch of no communication, no throttle because again, nothing is connected. We can go back. I want to go over to data stream and I just want to select the temperatures because again, all I have is a coolant temperature connected and we have 120 degrees. Okay, now again, this is in Spanish because it's from them, but I can change that value here, right? So I will be doing this and see if the computer responds, and it does. So you can see it went down to 84 and it's keep going down because I just went completely down. I'm going to go up and it's going up. That tells me the computer is completely alive and communicating. I have full control of that coolant temperature sensor. I got a healthy communication. Everything is good. I don't see any problems with, with this computer. So, yeah, this is how I check these computers in here. I know that it might be a little long video, but you know what? It's just the way it takes, the time it takes. This is not a something simple. Some people think like, how can you check my computer? Guys, I don't have a vehicle to go and plug every single computer there is in the world. I have to do this, study, see how the communication works, powers and grounds. What do I need to make that computer work? How is the network should look? And then go from there. If you guys want to see, um, I mean, we have that on. Let me try to go out. We know well the computer is working 100%, so that is not an issue. I don't need to stay here longer for this on this part of the screen. I just want to see the pinout test that this tool has. Did I went too far? Let me see in a scan. I think I can get it in there. Yes, pin detection. Let's try to detect it again and see if it gives me anything else. Yes. At least you see it says where the CAN bus. You see what one thing that I want to show, and I gotta get familiar with the tool as well, is when I have a healthy communication. You see 2.4 and 2.6. That's what I might want to see. And it says CAN bus pins 6 and 14 and results of resistance. Again, this is the resistance with the computer power up. So this is not like, a resistance with the computer off, which then this tool will not read anything because it's off. And I needed to have it on in order to provide that terminator resistance that I am actually providing myself in here. But yeah, this computer, it has absolutely nothing wrong. Now what is here for, so Sashan, I'm going to call you and let you know that, yeah, there is absolutely nothing wrong with the computer. I need to access it and make sure there is, like I did in here, open the computer and make sure there is no water intrusion because sometimes computer can dry it up In the time that you bring it over to me, I get communication. If I don't open that computer, it might be completely corroded, and all it needs is a little temperature that I cannot really reproduce so much temperature and vibration from the vehicle because in here I can just load this computer so much. When you make an engine run and you have injectors going, valves and spark plugs and all the coils and etc., then these start to produce heat. That's what this computer has this huge heat sink. That's not just built on aluminum. That has a reason. That's a heat dissipator. So that's why it's so important to have it like that, right? So that's why I open the computers up. I need to open the computer, test it correctly, and give my complete diagnosis to the customer and tell them, yes, there's absolutely nothing wrong with this computer. The problem is definitely in the car. You're gonna have to look into with as much as information I have shared in here. I think you got a good foundation to go over the vehicle and see what the gateway might be the problem. Check your gateway, powers and grounds, and make sure that you have communication. It has to have that CAN D coming out. You can might have a CAN E, which is again in between the computers and the car might run. But if you're missing that CAN-D, which goes from the gateway to the diagnostic port, then that's it. Make sure that your terminal resistance are there. Measure 60 ohms at pin 6 and 14. Battery off, battery disconnected. Make sure that you do those tests. Okay, guys, I'm a little tired from gathering all the information and trying to prepare a good video presentation for what I have here. I'm very happy, very, very happy the way my lab came come out, the way I now have it laid out because it was completely different. That table was there. You guys know because you've been seeing my videos. And right now, this is so much more room. I can actually just turn around, grab whatever computer I have in here, turn around, and then come back to work in here. This is just fantastic. It's like perfect, perfect. I am very, very happy. And I'm also very, very happy with this new tool that I can provide terminal rate assistance. I can see the fiber reference in there. I mean, this is great. This is a good tool as well. It's very handy. It's very powerful as well. Digital for me is the way to go. I actually going to request that company because I don't see a way to actually go full screen. I would like to have that window. That's the only reason I have this all like that is because this is as big as I can go. I don't see, I can minimize this, but that's as big as it goes. I would like to have this full screen. I would like to also to have, I don't know why they have in the temperature sensor, they got 43%. What does that 43% means? I would like to read temperature or I don't know if they're not taking the actual reading from the computer because they can, if they have communication with the scanner like I do right now, they can read the values in here, but I might be wrong. So just thoughts and things that I have in my mind. I'm always thinking of new projects and new ideas, trying to share as much information I can with you too. Again, this is a customer right here from Virginia, and this is what we do. So thank you so much for visiting the channel. Don't forget to subscribe. I will try to put this all together and make it as short as possible, but I don't want to cut any good information. I know some people says, "Oh, your videos are too long." I'm sorry, but that's just the way they are. I like to do things for helping others and not just to show what I can do because this is a lot of people are trying to do this as well, and I want to help them out. So thank you so much. See you next time. Bye bye.